I'm working on the open source.
That's right.
Okay.
And then split. Perfect. Okay, cool. So we'll leave it like this and then we'll change it.
What does that mean?
It is Japanese. In Japanese lore, there's a shape-shifting honey badger.
What does it shape shift into?
In Japanese lore, I don't really know, but our idea was that since the software is portable to different types of
Oh yeah,
ASICs and
random
hardware,
wise, it's very cool.
Yeah.
I love the honey badger stuff.
Well, it was, they got up
Yeah.
to like 97.
Classic, yeah, big clear. It's a robot.
It's not
It's not really anything you're saying.
You're right.
Maybe it's just
No, that's why you're on the hot shape.
Oh,
Yeah.
Yeah, we just started. So, no big demos yet.
Do you have
Maybe next year.
So for running BitX draw, I have also put in the power. Yes. Power supply plus the USB.
something is wrong.
And then you just get a serial, and then it's commenced.
Yeah, you get two serial.
It's just a bus.
You can do two serial plugs. One is for. Well, it says this in the XR repo. One is some control stuff, like if you want to turn fans on.
Make sure
It's
that
Restart the
like the control channel. And the other is a straight through stick.
public. Or did it move?
Not.
I was pretty
You sent me to the already.
Oh, yeah.
It isn't normal.
Yeah, it's fine.
How does the repo look like? Is it a Rust crate?
It's a Rust workspace.
Are you using cargo build, like build.rs or anything?
Oh, you mind?
It's not.
So if you go to the Explorer, we should see the lock gun.
Build needs to be. It can be tested on the deck.
You can try development and then start scaling it out.
Just now.
BitX is sort of like
You might not
if you open a single cell dashboard, unitary atomic dashboard.
You see here, and you can test on it someone on the it's still pretty trivial.
Right.
It's,
Not a CPU.
right, exactly.
Alright, we're rich now.
Yeah, that's right. I made that.
That's right.
I paid him out for his share.
And, you got like 40s.
I just got to recall his back.
That's right. All of them are CPU.
Yeah, I'm looking at it's $5 million for 50 Bitcoin.
Pretty cool.
On it?
Yeah, we
Yeah,
got it.
yeah.
Try it. On bit.
Welcome to the
Jordan was, that's my.
BitX is nice.
All right. Thanks a lot, guys.
It's,
This I hope you guys learned something. I
So
hope
Did
you
they
got-
mine one?
Huh?
Did they mine one?
Yes.
it wouldn't be classic pretty good.
Yeah,
I
you
hope
guys
this
got some blocks.
sells the idea of strategy to
Yeah.
you guys, and you hopefully can convince people to use it on text and mining.
You did all the hard parts.
Sorry?
You did the hard part.
Oh yeah, I just wanna give you an experience.
But yes, thank you for the experience.
Yeah, thank you.
Do you do things with dollars? With Blockstream?
I'm just a user,
Oh,
but I bought a t-shirt.
very cool.
Hey,
Hey, we just mined like 5 blocks.
Yeah.
We are rich at 50 each.
decentralized templates.
Remember me from Italy?
Of course.
From
No.
that
was at Summit, right?
Not yet.
How are you doing?
Alright. Looking forward to your talk too.
I'm done.
Oh, it's done. Oh,
You missed it.
yeah.
What was the talk about?
That was a quality demo, guys. Thank you.
Well,
That you're relieved that it worked.
Yes, I was very prepared of accepting the possibility that it was gonna flop, but apparently the USB alternative works as long as people trust it to some degree.
Well, if it's for DEF CON, no.
Yeah. No, but I mean, miners are they're skeptical and they're like they're very easily spooked out. So
Yeah, a guy who joined later didn't trust me.
yeah.
I tried to convince him, but nothing. It didn't work.
what are you doing? Are you working with money? No. I have like a bit axe at home.
What happened there?
Well, so it kind of ended up just like dropping off for other stuff, but I think people in the organization are kind of leaning into it a little bit.
What about you, Wendy?
I don't think concentration on one somewhat because you need more
Yeah, so, well, the main idea is like, if the network goes down, we want the miners to keep consuming power. If we have like a power obligation, like we have to use this certain amount, then at least having the miners still running will let us meet that. So that was kind of like the starting point. And then recently we've been using this proxy. We've been trying proxy our traffic because we actually got to the point where there was like NAT port exhaustion on our network from too many miners trying to reach out at the same time. I tried to bring proxy and that one was pretty good. Where when you're hashing to a pool, you can still keep track of your individual workers even when you're proxy. The Foundry pool doesn't allow that with branch proxy. They only let you do it if you use their Foundry proxy.
We're working on trying to standardize.
Oh, trying to like make that more of a standard? Okay.
Yeah, it's trying to be too like bigger phones protocol doesn't mean you don't have to do that, and then the proxies aggregate hash rate using that granularity. But we're working on this protocol also extensions. And we have already
was trying to test with your stuff, I remember I had to use that translator, and that sort of thing. But yeah, I mean, I think we have a lot better of infrastructure now to run this sort of stuff. Because when I first started, they were running everything on like Windows VMs, and so trying to like run that SV2 binary, even in whether in Docker or not, was kind of a pain. But now I have like a cluster set up where I can just like push containers to it. So yeah, I mean, I'd definitely be interested in doing some more testing with the SV2 and backup pool, and I know there was even.
Dude, this code base that I guess you weren't running with it's a solo mining.
Solo mining.
There's no share count, right? We're actually working on some refactoring where very soon we're gonna have the shares going to be there if you want to look at what's database. The API will be a little bit more friendly to do that. But also you're not like trying to set one cookie and the entire code base goes there, it's locked there.
Okay.
But it sounds like
Yeah.
one is a little bit more fancy than that.
No.
Perhaps if there are some primitives for internal control, right? So you can like, okay, the proof of work is arriving here on this point, and I can see that the hash rate cannot get lost.
Yeah.
Thinking that I'm mining, that I'm solo mining. Because it will take a while before the final block can get confirmation, right? But right now you don't really, I mean, unless you do it yourself, you have to code, you don't have a lot of functionality to keep track of work as it arrives there. I mean, you get the message and
Just goes in some log somewhere.
that's it. We are changing it such that in memory, we're going to have some counters there, like we're counting the amount of shares. There's a share indexer that is sort of like leading to. There's also an accumulator for difficulty, right? So you keep summing the difficulty and all of that for each state, for each channel, you always have this stateful in memory.
You're in here, right? I'm admiring the setup. They were asking us to do that. Cool. You got that. Man, that is impressive. Very good. Cool. I think that's what I feel this is.
Yeah.
You need to get on with it.
So,
We're in the room. Oh, okay, I see
do
that.
we have any audio?
I mean, I can talk loud enough for the whole room, but if it's important for the recording.
Yeah, I think so.
Okay.
Here, let me unmute it. Try again.
Okay, I'm gonna switch to, since they're live, the other one. Nice.
Let's go. This is how the sausage is made. Hello. Hi. You ready? Yeah. Go ahead.
We'll go one.
We're happy with that.
Can you put it on? You're talking to the back of the mic.
No, that's correct.
Oh, I'm sorry.
Let's go. I am slide one.
You look like you're ready to sell me a slap chop.
Let's go. Something is cool. And I can repeat questions if that's an issue.
Talk, talk, talk.
Sweet. Okay, let's go. Okay, well, let's go ahead and start. This talk's called Froster, Practical Application of Frost for the Individual. And yeah, I think it'll be pretty fun. We're gonna dive across a bunch of technical concepts, but I'm gonna try and make it easy for you. And then I'm gonna do the first half, and my partner is gonna come up here for the second half. So we're gonna talk about who we are, what is Frost, and then what is Froster. So let's get right into it. Who we are. I'm Austin, and this is Topher, and we worked on Froster initially in the TabConf 2024 hackathon where we won. And this was based off of Topher's previous work with Frost. And you know, he had a library, and he was seeing how it could be applied very simply and practically for the problem of having this single key on Nostr. And so that was sort of where the idea came from, and we've been, gosh, building on it since then, which is crazy to think. And there's so much more we want to do. So we're going to start with what is Frost? And boy, this is a big topic, but I'm going to try and make it easy. This is a graphic I put together for my mental map of Frost. So Frost is flexible, round, optimized Schnorr threshold signatures. It's a mouthful. It's a 2-round threshold signature scheme that allows a subset of participants to collaboratively produce a valid signature without requiring a trusted dealer or revealing any individual secret keys. So you're going to know exactly what that means with all the fancy terminology at the end, but basically what it means is a group of people that don't trust each other can take a single secret, split it up amongst themselves, and use that secret to sign. And that even that signature that comes out on the other end is not obviously collaboratively created. Okay, so this is our map of Frost. We start with this first step where shares are generated. We take a secret, is split up into keys. And then there's this DKG or TD thing. What does that mean? Well, shares are collected and distributed, okay? Commits are collected and distributed. And then signatures are collected and an aggregator is selected. So that is kind of the full life cycle of Frost. And let's walk through each of these steps and learn these concepts. So Shamir secret sharing. This is the way that you can split up your secret, your single secret, into multiple shares. So you only need a minimum predetermined number of these shares to reconstruct your original secret. And this is really, it is like you have a curve. And where that curve intersects at the axis is your secret. And then we can create a function to determine what points you need and what threshold of points to get back to that secret. So it's actually really, really simple and elegant. You're just taking the secret, you're kind of extrapolating it out into a function, and you're picking points to where however many keys and what threshold of those keys you want can lead back to the secret. So that is Shamir in a very basic level. And so that's what we do to split up our secret. That's a big value add right there, and it's quite simple to do actually. And then we have this step right here where we collect and distribute shares. We're going to talk about DKG or TD. So trusted dealer and DKG, there's 2 different ways of distributing these keys, these shares, over to different members in the group. There's the trusted dealer and then the untrusted DKG. So this is the trusted dealer setup, very simple. You have a secret, you hand it over to Alice, Bob, and Carol. On the untrusted side, you have a DKG, distributed key generation. It's a little more complicated. It has a few more steps, but this is from Alice's perspective. We're kind of trying to play color matching, right? Alice, Bob, and Carol, they each generated their own sets of keys, and they want to swap them in this ordered way based on their index to where all of them have the same color of keys. And that can basically be extrapolated back to the original secret. So then they effectively end up with their blue, red, and green keys there. So this is from Alice's perspective. You see how she has to keep one for herself, give one to Bob, give one to Carol, and then Bob and Carol would have to do the same for that to do the DKG. Okay, and so that's the idea of how we collect our share, distribute our shares, and all end up with our own keys without the secret remaining anywhere at once. So next is the idea of commits. Before we sign, we are going to commit to what we sign because we don't trust each other. So first we need the idea of nonces to understand this. So nonces is used in all across cryptography, and it's basically this idea that you want to ensure uniqueness for each signature, and you want to add randomness to the signing process. So if I just sign some message with my raw private key, you know, that signature, it's kind of naked, something about it. And if I get the stamp of a nonce and I stamp that, I can add kind of some redundancy, some uniqueness to each signature, even though I'm signing the same private key. So that's kind of an abstracted explanation of that. And how this applies in Frost is with the commitment scheme. You know, if we have like Alice and Bob over here, really before we even sign, we're going to say, hey, when I sign, I'm going to stamp my paper with this stamp. And I'm going to give you this stamp just so you can uniquely see it and you know what to expect from me. And so Alice does that process, creates kind of the stamped message, unsigned, hands it over to Bob. Bob does the same. Okay, we know we're committed to this. I know what to expect from you. Yeah, and this has to happen in the full round, right? So this is one of the rounds in Frost. And so that is round one. We collect and distribute the commits in this circle of our group. And then we have to select an aggregator and collect signatures. That basically is the idea of who's going to have the final threshold of signatures and then broadcast the message. And so we'll talk about the concepts within these. Just a quick piece on partial signatures and aggregation. You know, we can aggregate all of our signatures together into one valid signature. And of course, that's because it's using Schnorr signatures. It's very elegant doing it as Schnorr signatures. And yeah, in Frost, this allows multiple participants to contribute their partial signatures. And then on the outside, you can't really tell it was created by multiple parties. So that's partial signatures and aggregation. And then just the thresholds is the idea that maybe if Bob is offline here, then we can still probably meet the threshold, just like we only need maybe 2 points, maybe 3 of 5 points to get back to the secret. So threshold is met, and we can get back to that same aggregated signature all the same. And so there we go. That's basically Frost. And the one thing I guess I abstracted away is the rounds, because Frost is flexible round optimized. The way that these commits and then signatures are passed around is efficient to try and reduce the number of rounds. Because the more interactivity we have, it's more difficult to implement. There's more security holes. It's just harder to do. So that's one of the big ideas with Frost. And kind of with that context in mind, we can show you how we have tweaked this a little bit for our use case. So we'll talk about what is Froster, and I'll have Topher come up here.
Hello, hello. Hope you all can hear me. Okay, so I got my notes right here that I'm going to be reading off of. So what is Froster? Let's just get right into it. So Froster, it's a hyper-optimized version of Frost. That's the word that I like to use. Frost is optimized down to 2 rounds. And because Frost is sort of tailored for an adversarial environment, you don't exactly trust the people that you're dealing with. There's a lot of security considerations that goes into how do you communicate with people in that context. And so the people that worked on Frost, they managed to get it down to 2 rounds of communication, which is great. It used to be a lot more than that. But we're sort of operating in a different context because with Froster, we're not looking to deal with adversaries. We're just looking to deal with a single user that wants to protect themselves by splitting up their key into multiple pieces and then distributing that so that their key is not in one place at any one given time. And so you're not necessarily an adversary with yourself, which means that there's some things in Frost that you can maybe optimize for the individual. And get some optimizations there. So that's what I mean by Froster is a hyper-optimized version of Frost designed for the single user. It allows an individual to break up their secret key. And we do that using a trusted dealer. So Austin explained what a trusted dealer is. Essentially, you're taking it, somebody has the secret key at one point, and they do the Shamir process to split it up into shares. And it's a trusted dealer because you're trusting that person since they have the key at that point. They know the secret. With DKG, you can get around that, so where like nobody actually knows the secret in a DKG process. But we don't have to worry about that because we're the individual. Like we know what our secret is, and that's okay. So in Froster, we use a trusted dealer. Another thing that we do is we generate the shares and the nonces up front. So in Frost, even if you go through the DKG process and generate the shares that you all sign with, you still have that commitment round where you will generate nonces when you want to sign. And that means that every time you want to sign something, you now have to go through this process of generating nonces, committing to them, showing them to your peers, making sure that everybody knows which nonce every other person's going to be using in a signing round. So that's a whole round of communication that you have to do in Frost, but we don't necessarily have to do that in Froster. So that's like one of the benefits that we're going to talk about. Also, we're going to do some cool things with key extension, where nonces can actually be extended, similar to how keys can be extended, like with an HD wallet. You can take a single key and actually make many more keys out of it. So we're going to be going over that. And one thing I want to mention is that what I'm going to show you and the things that we do with Froster, we don't modify the Frost protocol in any way. So the things that we do are meant to wrap over Frost, but the actual protocol that is in the Frost specification, we do not modify that in any way. So it's still Frost happening underneath the hood. And just to explain what the R means, all of this is done over Nostr relays, which is kind of cool. So I just want to talk about this topic real quick. Nostr key management sucks. And why is that? Well, it's because your identity is a single key, which isn't that bad. I mean, it's easy that you just have one key, one account. That makes sense. But then right now, like, you have to paste that key everywhere. Like, to log in, you have to give up your secret key. That's not good. Also, I kind of have this saying I say to myself, there's no crying in baseball. There's also no account recovery in Nostr. You lose your key, your account is gone. If your key gets stolen, your account now has become a public bathroom. And anybody can post whatever they want under your name. So we need to fix that. Like, there needs to be a better solution for doing key management over Nostr. So this is the jump that we're going to make. We're going to talk about how we go from Frost to where we have all of these different steps that we need to go through, to Froster, where we can eliminate a lot of this stuff and just focus on doing the protocol for the individual. We're going to go from this to this, which is a lot nicer. So let's start here. Like, how do we generate the shares? So Austin talked about how we do Trusted Dealer. So that's what we're using. The cool thing about Trusted Dealer versus a DKG is that you can bring your own secret key. So I think that's really cool. So with the DKG, you can't do that. You basically, the process that you have to go through means that whatever underlying secret is generated for your group, you don't get to decide that. It's just random. But with Trusted Dealer, you can actually choose what key you're splitting up. So you can bring your own existing NSEC into this process and make it a Froster key. And I don't have to go into the Shamir process because Austin already covered that, so I just put the Shamir fairy up there. So you have your secret key, you give it to the Shamir fairy. She breaks it up for you, and you decide, like, okay, how many shares do you want to create? So we're doing a 2 of 3 here. So we're going to create 3 shares, and we're going to set it up so we only need 2 to sign. And one thing that we're doing differently is that during Trusted Dealer, we generate the shares. We also generate the nonces ahead of time. And we're doing this so that we can get rid of one of the rounds, which is the commitment round. And then I'll show you how we do that. So in Frost, the commitment round, you basically share this package of public data, which is a public commitment to your nonce. We do all this up front, and that's the group package. So imagine that you want to split up your key. You split it up into these share packages. You also have this group package that contains all the public information that's safe to be public, although you might want to keep it private anyways. And this is the information you're going to distribute to your different devices. It's this information here. And being that you're not an adversary with yourself, like it's very easy to do distribution. You can carefully copy paste this, DM it to yourself, like however you want to move this data around. But if you can get this data onto other devices, that's all the distribution is. This is how do you get it to other devices. So now let's talk about how we're going to do these virtualized commitment rounds. So basically, what the cool thing with Froster is because we're doing the commitment round in advance, and we're not doing it with each signature, we can actually sign a lot of things at once. And so that's what Froster is designed to do. It's instead of doing a single 2-round signing process, we actually set up something called a session, a signing session. And in that session, you can actually sign multiple things at once. And so that's what this little session package does. We basically are outlining, okay, these are the people that are going to be participating. These are the messages that we're going to sign. You can also throw some additional data in there if you want, like a timestamp or some additional content, maybe a PSBT if this is a transaction that you're signing. And then from that, we create this thing called a binder. This is something that is used in Frost, but we're also using it for our own purposes here. And all we're doing is we're creating a commitment such that when we do our nonce extension, we want to make sure that when we extend our nonce, the final nonce that we get out of that is unique to the thing that we're signing. We just want to make sure that that's true. So this is a process that we go through to ensure that. If you just want to see what the sausage factory looks like on the inside. So I'll run through this real quick. You create a session package that commits to everything. We hash that down to a single hash. That's your session ID. We then do key derivation, similar to what you would see with an HD wallet. So there's these little paths that you can sort of imagine. But if we're signing 2 messages with 2 people, we essentially have to generate 4 unique nonces, 2 for each person. And so we create our binder in this particular way where we take the session ID, we take the message that we're signing, and the index of that particular member, and we can hash that, and then that becomes our binder, and we can use that to tweak that user's nonce so that we get a unique nonce that we can use for a particular signature that we're going to sign. And the cool thing about that is we don't have to talk to each other to do this. As long as you have this group package, that means for any session that is passed to you, you can generate all the nonces that are going to be used for signing. You can just generate them. You don't have to talk to anybody in order to figure out what nonces to use. You can just generate it. And by the way, these are commitments. So like they're not the actual nonces. These are the public point version of the nonces. So it's the stuff that you would normally pass around anyway. So then now that we've skipped the commitment round, we can just really go straight to collecting signatures. And so collecting signatures is rather simple. Let's say we have 3 nodes that are running Froster, and then we'll do this from the perspective of the Alice node. So like Alice wants to sign a PSBT. And so there's multiple inputs in that PSBT that Alice needs to have signed. And so how does she get the partial signatures for that PSBT so she can aggregate them together and get the complete signatures that she needs? And we essentially just do this over Nostr notes. All your shares that you get, they're secret keys in of themselves, and so they also have a public key. And so you can use that as its own identity on Nostr, which means all these nodes have their own unique Nostr identity. And they just talk to each other. We communicate using Nostr notes. Everything's end-to-end encrypted. And so Alice will just go, hey, I need to collect some signatures. Let's say we need to collect 2 signatures, so Alice can just send a request out to Bob. And at the same time, Alice can send a request out to Carol asynchronously. Bob and Carol can generate the commitment round virtually. They don't need to talk to each other. They just know how to pre-compute this stuff. And that allows them to produce a signature. And then they turn around and they send their signature package back to Alice. And now Alice has a signature. And so this is a simple 1-round request and response that everybody's familiar with asynchronous handling, which is fantastic, because then that means you can scale this really, really well. And with that, you can then start thinking about, well, how do I build my own Froster network? So we designed the software so that it can run anywhere. I mean, the idea is you run it on your desktop, laptop, smartphone. if you have a home server, or maybe there's some third-party VPS that you want to run this on, and they all just connect through the Nostr network. And because of the properties that Nostr gives you, this could be behind a firewall, this can be deeply behind several NATs. You don't have to worry about NAT traversal. You can run this anywhere. You can even run it in the browser, and you can have a browser tab act as a signing node. So the idea is that you can build your own signing network over Nostr. And is this the video? Just a little video of what this looks like. So we have two signing clients out right now. One is Igloo. Igloo is the desktop client. That's what helps you split up your key into different shares. And so what Austin's showing is he's using the Igloo desktop app along with the, we have a fork of the NOS2x extension called Frost2x, so it's a browser extension that also does signing. And it happens so fast that it already happened. I didn't even have a chance to show you that it happened. So let's kind of look at it again real quick. So yeah, so you have Igloo running on one side. You have your Frost2x signing extension, browser extension on the other side. And when you go to sign a note, oh, the chicken's done. One more time. I'm going a little overtime. But yeah, so if you want to post something on Nostr, you know, from the Nostr client's perspective, it's just some signing device communicating over NIP7 or NIP46. The Nostr client doesn't know that this is happening in the background. So the moment you go to post a note and that Nostr client requests a signature, your Froster node knows, okay, time to reach out to the network, grab the partial signatures that I need, they come back, create the final signature, here you go. And it happens within like less than a second. Like it's really, really, really fast. So I wish we had a better way to show just how fast this is, but you would have to like spam the Nostr network, I guess, to show like how fast you can produce signatures and publish things. But it's really, really, really fast. Since we're running out of time, hold on. I will take questions at the end. I just want to get through this final point, which is, I think, really important, maybe even the most important, and that is key rotation. So key rotation currently doesn't exist in Nostr. But in Froster, key rotation is very simple. Because we use a trusted dealer, you don't have to go through any complicated protocol. You simply just go through the trusted dealer setup again, and you'll get completely brand new shares. And those shares are always unique to each other, and they only work with each other. So if you have an existing set of shares that are already distributed and one of them gets compromised, you know what to do. You just basically kill them off and dispose of them, generate new shares, and replace them. And that's all you have to do. And because there's randomness involved in the generation process, you can do this as many times as you like. You'll always get a new set of random shares each and every time. Those shares will only work with each other. They will not work with shares from other generation rounds. And so that's how you do key rotation. It's incredibly simple. I feel like anybody can wrap their hand around it. You don't have to kill the younglings, though. So yeah, underneath the hood, Bifrost is the node that makes all of this happen. It's designed to be like a peer-to-peer nodes, like Bitcoin, where you just throw them up wherever you can run one, and they'll all figure out how to reach out and connect to each other using Nostr. And these are the two underlying libraries that power Bifrost. It's a Nostr P2P library, and then the Frost library, all open source, by the way, so have at it. And what can you do with Froster? Man, what can't you do? You can pretty much do anything and everything that requires a digital signature. So Froster implements, it implements a lot of things, and there's just a few specific things I want to call out. So Froster supports Taproot. Froster also supports using HD wallets. I want to thank the people that worked on Music 2 for this, because Froster uses the Music 2 accumulator, which is like a really complex, really cool piece of kit that they developed for Musig in order to make sure that multi-sig Schnorr will work with HD wallets. So we also use that in Froster, which means that Froster will work with HD wallets. It'll sign Bitcoin transactions. It'll sign Taproot transactions. And the idea is that we are starting with a signing client. We want to build that into a wallet. And we want to open that up to where a Froster wallet is essentially the wallet that you go to build any sort of peer-to-peer protocol using Bitcoin. So that includes coin pools, coin joins, like any kind of protocol that you can think of, and anything that I can't think of. So yeah, so just to wrap this up, please come check us out if you want to learn more. Our website is froster.org. It's pretty cool. Austin built all of this, and he's a great designer, so I think it looks pretty sleek. And yeah, if you have any questions for me, I'm already over time, but feel free to find me or Austin in the back after the talk. Thank you.
Cool. Hey, everyone. My name's Eric. I work at Foundry. I'm a data analyst. I lead a small team of analysts, and I work under the director of data with some data engineers as well. So we're kind of the central data platform team. We've got a bunch of applications, third-party data providers, the on-chain Bitcoin data. All this stuff sort of funnels into a central data platform. And then that's where I come in and sort of do a lot of modeling and data transformations to turn that into something that could be plugged into some kind of report or a dashboard. So I'm mostly serving our internal stakeholders with this stuff, but also some things get shared between applications, and maybe potentially in the long run, maybe some direct data monetization type products. So that's a little bit about me. If, by the way, I'm going to do a quick slideshow presentation on some data modeling sort of fundamental concepts, giving examples with on-chain data, and then we'll do a workshop where we'll build some of these models out. So if anyone would like to participate in the workshop and run the models themselves, there's a GitHub repo here. It's github.com SHA-250, and then you'll see probably one of the pinned repos is BTC++ demo 2025. There's a Docker container with some setup instructions. It's going to like load the sample data for you, and you'll be all set to run some queries. Cool. So just first of all, little intro to analytics engineering. It's kind of a trendy term in the data world these days. Basically, we're taking all this source data from, again, like different applications or data providers. Sometimes it's very messy, if it's like user input type data, whatever it is, we're cleaning that up. We're sort of turning that into something that you could like look at, again, in a dashboard, or something you could make a decision off of as a business executive or those sorts of things. So the analogy here is, the raw tables or raw data are the ingredients, and the models are the recipes. So you're, combining these different data sources into something consumable. Yeah, I'm going to run through some of this stuff pretty quickly. Data engineers typically are just building the pipelines and the infrastructure to pull all the data in. Traditionally, analysts are doing these kind of ad hoc reports, or maybe making something in a Tableau or a Power BI. But where analytics engineering sort of sits in the middle of the two, where we're taking all the raw data and doing the transformations in a more automated and testable, and all the things that we love about software engineering and DevOps and stuff, all of that applied to the data modeling and transformations. So just some core concepts that we talk about. One of the biggest ones when you're building a data model is the granularity. So, if you think of it, so this is a daily table, is it an hourly table? Or in the Bitcoin world, are we talking like at a per block level or a per transaction level, these sorts of things? These are pretty simple, but you could get into a situation where you have a table that's, say, one row, per sub account, per IP address, or something along those lines, where you're splitting it on multiple dimensions in a single table. This idea of a natural versus surrogate key, within a data warehouse or an analytics database, however you want to call it, it is definitely advisable to generate your own surrogate keys there. So you always have a unique identifier that you know how that was generated deterministically, versus a natural key is what's coming from the source system. So if you're pulling data in from like your application MySQL database, we'll call that the natural key and generate a new surrogate key just for the purpose of the data warehouse. I'm going to skip over the change data capture. This is definitely an important one if you're into looking to learn more about data modeling. But normalized models versus denormalized models is another big concept. So normalized would be like splitting out each dimension into its own table. So you have like a proper date dimension with only one row per date, or you have a dimension of all the mining pools. That's your pool dimension as just one row per pool. Versus a denormalized would be like just one flat table. We'll see more examples of this. Yeah, so starting with those normalized schemas, star schema is an idea that I think came up early 1980s. Yeah, a lot of these concepts go way back. So this is that normalized approach where you're breaking out the separate dimension tables. So again, some examples, you got date or the pool or your specific customer. What kind of miner model is this? This is all your categorical data that you might be aggregating by or filtering some report on, where what we call a fact model is all your measurable events or your numerical data. What's your hash rate? How many miners were there of that particular model, right? So all those measurements or numerical data, we call those facts. Not really sure where the term fact came from. I think it's just, like this thing happened, we can measure it. I think that's the idea there. By the way, please stop me if anyone has questions on these terms or anything related. One of the pros to this like normalized data approach, originally, I think this came about, it was definitely a data storage question. Thinking back to the 80s, 90s, data storage was very limited. So they had to develop these type of models to not have all this duplicate data written to disk everywhere. But one of the benefits that we, and main reasons we still use star schemas is you have sort of these single tables that is like, this is the source of truth for what every mining pool is or what every block is. And you can kind of piece those things together, and it's very modular in that way. The cons being, you're always going to have to be joining your fact table to one or more dimension tables to create that full picture of your report or whatever your dashboard needs. And if you're just like a business analyst or someone used to Excel, it's probably not that intuitive to be making all the joins between tables. Moving on to what is called an OBT, an operational BI table. This is the opposite approach. This is very denormalized data. So just picture a spreadsheet, right? You have your date, you have your pool, you have how many blocks there were. So you have the dimensional attributes and the measurements or the numerical data all in one flat table. And this can get like pretty extreme where it's like, you could picture different partitions of this table, like filtering on this is for this one report, report A or report B, and you could have all that stuff just thrown into one flat table. That's, I'd say, pretty extreme. But yeah, so the pros of this approach, you don't have to always join different tables together, and it is more like a spreadsheet. It is probably more intuitive for your business users. But the main drawback here is you get a lot of code duplication, a lot of duplicate data written to disk, and you lose that having that like central source of truth for, again, like who each mining pool is or whatever your dimensions are. So what I like to do and what's pretty common in at least in like a business intelligence or that type of analytics world is you kind of do both. So you build your star schemas for all your primary dimensions at least, and then you kind of layer these OBT models on top of them, but it might just be an OBT for each dashboard or for each report. So you're not getting into these like crazy large wide tables. It's just like you're laying these on for a specific application. So before we get into the demo, just some other things to mention about building inside of a data warehouse. There's a tool called DBT, which really popularized the term analytics engineering. And I think about this like a front-end JavaScript framework, but it's for building data models. If you've ever done a lot of database work and you have these like sequential migration files, you have to run like 40 files in sequence for everything to line up right. This removes all that. And it's much more just like executing a code, a program, and it's smart enough to sense all the dependencies. So it says to build this model, I first have to build this model, which depends on this model. So it like builds the whole dependency lineage and builds everything in a smart way there. You also get a lot of automated testing and things like that through DBT. So we're not going to use DBT for the demo, but if anyone is curious about how that stuff works, it's definitely something I would recommend and enjoy using. Different types of databases. There are databases that are optimized for this type of analytical querying and just aggregates over very large data sets. So those are called columnar databases versus like a traditional Postgres or MySQL, which is a relational database. So these are some of the big cloud provider ones. You got your Snowflake, your BigQuery, but there's great open source columnar databases out there as well, DuckDB. Yeah, so this, back to the on-chain data now, this is kind of the stack that we've built to ingest data from the blockchain. So we're running on-prem the full Mempool space server, an API server with some custom API endpoints that the Mempool team developed for us as we sponsor them. So basically, we have this bulk blocks endpoint, and I have a link to that in the resources at the end. Basically, you can pull in like hundreds of blocks at once, and it's just one file for each block, and you get every possible attribute that you could ever want. Versus, the Mempools API, the public-facing one, you kind of have to make like 3 or 4 API calls per block to get all that data. So this made it really easy. We basically just monitor for new blocks coming in via their WebSocket. That triggers the whole pipeline to ingest a new block. Pipes into our database. This is DBT. Basically sits on top of our data warehouse layer and controls all of the transformations from the raw source data through something we call prep. This is where the heavy lifting of the transformations happen, and then finally gets written to tables in the DW layer or the data warehouse layer. Yeah.
Could you explain the data ingestion part a little more? I'm confused about the 2 paths there.
Sure. Yeah, so you have your Mempool WebSocket connection. This is just going to ping us whenever a new block is mined. And we're just running a Python script, but you could run whatever you want. So this is always listening to Mempool here. And when it hears about a new block, it's going to trigger this other Python script that just pulls in the data from the REST API endpoint.
Oh, okay, so the WebSocket just pings that a new block is present, then you have to go ask for the data along with the web. Okay.
Yeah, exactly. And we have this intermediate hop in between. It gets written to an object store in case you wanted to do something else with that block data that's not related to your data warehouse. So you could totally skip that and just pipe it right into a Postgres or whatever database you're using.
And do you store JSON?
Yeah, we prefer to do, and I think might have skipped over it, but we prefer to do all the data transformations once the raw data has hit this first layer inside the data warehouse. So I think if I go back, so the old approach was ETL. You might have heard this term. It's extract, transform, load. The more modern approach to this is extract, load, and then transform. So you just load all your data from however many, dozens of sources you have, and you control all your transformations after that in one central place. So then just some on-chain data models that we're going to get into here. For those dimensions, you're always going to need a date dimension. And I'll show you why that's kind of important once we get into it. We're going to build a block dimension, a pool, and we're going to skip the coin dimension because we're only talking about Bitcoin here. But depending on what company you work for, you might deal with other coins. You might need a coin dimension. So these are just some examples. For those fact tables, we're going to have a fact for the block data, so like how many transactions were there, what was the block rewards, all the measured data, what was the network difficulty. Then in addition to the on-chain data, I also added the Bitcoin price, daily price, and I have our pool hash rate, so Foundry's hash rate. I didn't add other pools, but if you can get the actual hash rate of other pools, you can add that in here, and we can do some interesting stuff like mining luck there. So finally, then we're going to bring those together into these denormalized OBT models. So this is just an example of of a star schema. You have your pool stats daily fact table, so that joins to the date dimension. It could join to the coin dimension if you had multiple coins, and it joins to the pool dimension. So it's one row per pool per day and potentially per different coin. That's the normalized star schema approach, and then we're going to layer on these OBT denormalized models on top of those star schemas. So we're going to then recombine all the DIMs and the facts into these OBT models and have that like flat report ready view. Yeah. Yeah, so the question was if there's data duplication issues potentially in these models. there can be, especially once you get into the OBT layer, if you have those flat denormalized models, you will almost definitely have data duplication. You could still, in a star schema, if you have different fact tables, you could have some data duplication there. But definitely, the idea of the dimension tables is to remove the duplicate data. So overall, you'll have much less duplicate data in a star schema than in these denormalized views here. Did that answer? Any other questions before we move on to the SQL coding section? Yeah.
So the date dimension table is broken down by like calendar date, right? Like 1 row per day of the year. So what would it look like if you want to like have higher resolution data?
Yeah, good question. So yes, the date dimension is always just going to be 1 row per date. I have seen time dimensions as well, and you could define that at an hourly level or a minute or a second level. What I typically do is just, if you have to go more granular than a daily level, you just include the exact timestamp in the fact table itself. But both approaches are totally valid. Like if you were doing all your analysis on an hourly basis, it might make sense to have an hourly grain time dimension. Did you have something?
I was going to say, like, so that time granularity you success, you pick as that date dimension should be whatever you're going to use.
Yeah, you could have all of the above if you need. If you were in a situation where you had like thousands of data models building, or hundreds of data sources, it might make sense to have an hour dimension, a minute dimension, and a second. But you're not going to typically wouldn't have like date and time combined into a single dimension, because then you have like every second of today and every second of tomorrow, and the next day you would probably separate it out into a date and a separate time dimension. Yeah, I don't know how common that is. I've never seen anyone like use the time dimension to a large extent, but probably at a depending on what you're doing, it could make sense. Cool. Any other questions before we move on to the workshop portion? Where's my timer, by the way? Oh, missed it. Okay. Cool. All right. So yeah, if anyone wants to follow along, this is the repo, and it has some setup instructions for the Docker container. Let me pull up the repo here. Yeah, so our Docker container is going to contain Postgres, pgadmin, which is just a graphical interface for Postgres, and then I've got some stuff to automatically load the sample data that we're going to use. So yeah, let's fire it up. And we can go a couple ways with this. Like I basically have a bunch of pre-written models because I wasn't sure how long it would take to get through everything. That we'll build the first couple, and then if we want, we can kind of like paste in the rest of them, and then we can get to some maybe more interesting stuff at the end. And if we have ideas of like questions we want to answer, we can try to write some ad hoc query type stuff. So I'm going to spin up this container. And if anyone's following along, it should just be admin@admin.com. Password is Postgres. And we're going to make the connection to the Postgres database running inside the same container. We're going to name it Postgres, and then if you come over to this connection tab, the host name is also Postgres, the username is Postgres, and the password is Postgres. And then we should have a successful connection here. Was anyone able to get that connection working? Okay, yeah. I did try to limit the sample data size, but it could still be a bit slow. So if you run into any questions, let me know. So let's see what we got. Actually, before we go any further, since I just rebuilt the Docker container, I'm going to change a couple settings in here. So first thing, obviously, we're going to go to dark mode. Okay. And then there's a couple other things I want to change, which is in the query tool, I'm just going to turn on autocomplete. And I'm just going to add a keyboard shortcut for to execute my queries. I'm going to make that Command Enter. And to run the entire script, I'm going to make Command Option Enter. Okay, should be good. So yeah, before we start querying stuff, I'll just show you quickly in the Docker Compose, it ran these 6 migrations. So I created some schemas. I automatically built the date dimension. We'll look at it, but I didn't want to waste our time here building that from scratch. And then I just copied 4 sample CSVs into tables in Postgres. And so that went into our source schema. Yeah, so we can start seeing the data that we loaded in. Just going to close all this stuff out. So if we look in the source schema, we have 4 tables: block, hash rate, pool, and price. So let's look at the block data. So you can see all the normal stuff, obviously block height, hash, got the previous hash, your timestamp, difficulty, rewards, and transaction count. I limited it to this, again, just to try to keep the file size small. Did you have a question? Oh, sorry. So we'll just do a quick preview of what all our raw data is that we're working with. So this is the hash rate one. This is just daily hash rate of Foundry Pool. You know, you can pull this down freely from our API. And then, so that's a simple one, just daily hash rate. If we had other pools data in here, we could add that as well. This is the pool data source. This is where it got a little bit spicy. So we've got a pool key, you know, the human readable name and the URL, and then we have like whether each pool is part of the AMP pool mafia or not. And then there's one final data source, which is just the Bitcoin price. And this is, again, from a free API. Coinmetrics provides this daily grain BTC spot price, and they get like candlestick. You know, we're just going to use the daily price close as the one we're going to use. Okay, so the first model we're going to build, and again, going back to those star schemas, we're going to start with some dimension tables. We're going to build the pool dimension first because it's pretty straightforward. So I'm just going to rename this as dim pool. Oh, actually, yeah, I forgot to show you the date dimension as well. So we've got these are our schemas that we created. The source schema, the dim and the fact schema, those are going to go into our star, you know, the overall star schemas. And then the OBT is that like reporting view. So we automatically, in our migrations in the setup, we built the date dimension. So we'll just take a look at that quickly. So I would, even if you're doing like a small data, an analytics type database, I would always recommend having a date dimension. And this is why, you know, if you're just joining to any other fact table on the date ID, or, you know, if you don't want this ID, you just join on the date itself, you're going to get things like, you know, the day of the week, the week of the year, the day of the year, you know, all these different attributes that pertains to the day, you know, if it's true, false, if it's a weekend day or not. Like, these are the types of things that come in handy depending on what report you're building. So that's the date dimension, pre-built. We don't need to worry about that one. So yeah, so now we're going to get into building our pool dimension. So I do have in the repo, under this models directory, there's dims, facts, and the OBTs are the final layer for the report. So this is the dim pool. I'm going to try to build this one from scratch, but it's here for reference. So we're going to create table dim pool. And excuse me, I don't have my normal keyboard set up, so it might be a bit slow to type on this stuff. Yeah, so in the source data, we have the pool key, and this is that, if going back, this is the natural key, because this is coming from the source data, which is mempool.space. So they, they have this like identifier for each pool. So we're using that and calling it as pool key. Where it is recommended you do some like data cleaning on any string data. And yeah, let me just zoom through a couple of these. And then the URL. And then what else do we have? These Mempool Mafia flags. And then one thing that's always recommended, depending on where you're loading data from, there's always going to be probably some cases where you could wind up with duplicate data in your source or your raw layer. So ideally, you would have some kind of metadata timestamp that indicates like when was the data for this pool last updated, or if it lacking that, you can have like when did my pipeline last push it into my database. So you're going to want to use, like in most cases, the most recent row for each pool. Lacking that, because I just dumped this in here, I'm just going to fake one using the current system of my Postgres server. So I call this as the audit timestamp. You can call it updated timestamp, whatever you have there. But yeah, so we're going to use this to deduplicate any potentially duplicate data. So now I'm going to do, okay, so I needed a CTE here with source pool as, okay, so that's, by the way, I should have asked this at the start, is everyone sort of familiar with SQL, or has anyone like never written any SQL before? Someone, okay, got a few heads up, thumbs up. All right, so we're going to do a deduplicate step here. This is where you kind of have to do some code gymnastics with something like Postgres, where I'm used to using Snowflake, which has a lot of nice like built-ins where you don't have to have some of this extra code. But we're going to do this deduplicate step. So I'm just going to copy this one for time's sake and explain how it works. So we have this inner query here where we're selecting the data from that first CTE, source pool. And we're just going to select all the rows we had there, plus we're going to create a row number. We're going to partition it by each pool. So, and then we're going to order it by the audit timestamp, that metadata field that we kind of just faked in the beginning. And we're going to call that the dedupe row number. And we're going to use that dedupe row number in the outer query. We're going to, again, just select star, but where the row number equals 1. So again, we have one row for each pool key. That's our natural key from the source system, and we're ordering it by the most recent one based on that metadata. And then we only want the row where that row number equals 1. So the first one based on this order by. Does that kind of make sense? This basically just cleans up any duplicate data that you have in the raw layer. All right, so I'm just going to power on through here. So next we have the standardized block. This, don't necessarily need to do this, but depending on what kind of database you're using, it's good to specify the size of your varchars or the size of your numerical data, that type of thing. And this is an interesting one. I like to use these placeholder rows, and we'll see why when we start joining the dimensions to the fact tables. We're just going to add one for an unknown pool. The reason we do this, so we have all the data from the real pools that we got, that from that sample data we loaded in. We're going to add one extra row. So we're going to union that to one row here for an unknown pool. The reason we do this is like depending on when you're joining to some fact table, you might have data for a pool that your dim table doesn't know about. Ideally, you don't want to run into those situations. You want to always like build your dim tables before the fact tables. But you could run into that situation, and this just gives you like a placeholder. So that way you can always join your fact tables to the dimension table, and if it doesn't know what pool it is, it's going to just default to this unknown pool. In other models, it might make sense to have like an NA row or a all pools row. So this is where you can kind of like union in those placeholders. So again, just in the interest of time, I'm going to just paste it in at this point. So this is going to run through the whole script. We're going to drop if it exists, we're going to drop the dim table. Then we're going to create the dim table again. Basically all that code that we just went through, plus now we have that standardized layer with the extra row. So we're going to run all this, and we just got the first 1,000 rows here. So we also generated our surrogate key. Yeah, we'll just skip over that. But basically, we generated our own ID for the purpose of our data warehouse, right? And this is the natural key that came from Mempool. We have all the other fields, plus that audit timestamp. So let's just build out the rest of the dim tables and get to a fact table. So we're going to do a very similar thing here with the block data. This is just going to be one row per block, but it only has the categorical fields, like the block hash, the previous block hash. Yeah.
So like a lot of the steps that you're doing are very kind of like, assume there's been a ton of transformation that needs to be done to the data. If that was the case, would you done these steps or no?
Yeah, it could be either or. A lot of this is personal preference, but you want to deduplicate stuff. You probably want to specify your data types, precisely and things like that. In terms of where you're going to do your transformations, if there was a bunch of transformations happening before, you would probably want to do them before the standardized block, because that's where you're specifying, say, like the final column names or final data types. Yeah, and we'll have an example with some more complicated, this isn't really doing any transformations in this particular model. One thing with the block data I should mention, if you are sort of like following that pipeline ingestion, you're going to hear about blocks via this WebSocket that end up becoming stale, or what people sometimes call orphan blocks. So if you're building a block data table in your data warehouse, you have to have some way of checking that, and you can use just the hash and the previous hash and do a comparison. But yeah, I'm not doing that in this model. I know all the blocks that we have here are not stale blocks. Just wanted to call that out. Yeah.
So then do you want to have some way of saying, like, we promise the results, or you shouldn't do an analysis more than like X minutes current, right? Like you should only include results that are at least an hour or later, because that's what we have accountants for. Like, does that need to be included in the law?
Is the question that, are we only building the model for recent data?
No, more so like when I guess maybe at the final step or something, someone wants to build a report on this, and they're including data like that might be a stale block because it's run at the moment, like up to the second. Do you need to consider that or specify like, hey, how is that like something that you would set, that you would configure, or would you need to communicate that to the consumer of the data to make sure you're keeping this in mind when you're building a report?
Yeah, okay, so I think the question is more like, if we're doing this with real-time or near real-time data, and we're, say, like at the chain tip, do we want to indicate that this is the current block height in this example? Yeah, probably. I'm not really thinking in the terms of real-time, but yeah, if you were doing like a real-time data solution, you would probably want to indicate in some way that this is maybe not finalized yet, or that this block could become stale in this case.
Would it be something that you would want, like, would you want to take that into consideration for the user and like you make that determination
Yeah, I get it depends on the use case and who your users are probably, but yeah, you'd probably want to, if they thought they needed the up to the most recent block height, then you'd probably give them the full access, but have some field that indicates, you know, it's the current block height as of this timestamp or something. Mm-hmm.
So I think you had the first line was drop table if exists.
Okay, yeah.
Right? So is that like always how this block dimension table is going to work, or do we run this once and then we upsert?
Yeah, great question. Currently, this only is just like what I would call a full refresh table. So it's going to wipe the whole thing out and rebuild it every time I run this full script. And you can build your dimension tables, and oftentimes it's easier to build your dimension tables that way. You might run into performance, and then you have to do incrementally, or you might have to capture the way those dimensions are changing over time. Like if it's a company and they change their address, you might still need to associate some older data with their old address. That's called change data capture. But yeah, for the purpose of this, I'm just like wiping everything out, doing a full rebuild each time. Where the more incremental things come into play is when you're building those fact tables with the numerical data. That's at least in my case, and what I'm used to seeing is that's the places where you would have the incremental builds more typically. So say if it builds on a daily or an hourly schedule, it's only going to build for the previous day or the previous hour. And I basically when we get to the fact table here, I put a comment sort of hand waving away that complexity. But yeah, we're just doing a full refresh even in the fact tables here. But yeah, so if you're using something like DBT, which is that data modeling framework, it has ways to automate all this stuff, and you can have macros that compile to SQL and things that handle all the when is this building, and then it dynamically creates the filter conditions of what time period it should be building for and stuff like that. So let's just crank out these other dim tables and we can get to the fact here. So this is creating that block dimension table. And you'll see there's no numerical data here. We only have the categorical data. And we have some flags like, is this a difficulty adjustment block, or is it like the halving block? There's lots of other attributes that I just left out of the sample data that could have gone in here. And yeah, those are the only dimension tables we're going to build. And now the fact table block. So again, coming back to your question, this is the block. This is a model where probably if I was building this on a daily schedule, I would just build it for all the blocks on the previous day and just merge those into the existing table rather than doing this drop at the top. So this is a fact block. You could just have one block table, but the reason I separated it out into a dim and a fact at the block for the block data is maybe you're dealing with Bitcoin transaction level data or a bunch of data pertaining to particular Bitcoin addresses, and you want to join that to like what block something occurred at. That's where having a block dimension table makes a lot of sense. All right, so I want to get all the main tables built so we can get to like the reporting layer OBT views here. So we created our own block ID, just like any dimension is going to have its own ID. That's the surrogate key. And then this is what I call the natural key, is actually just the block hash that we all know. This is going to join back to the dim block. So here this is our, let's see, did I grab the right one? We're going to create now the fact block table. Yeah, so now this one has the block height, what subsidy epoch we're in, what difficulty epoch, what was the actual difficulty, what's the mining rewards, some aggregates about like what the average transaction fee was, things like that. So all the numerical data pertaining to each individual block is going to go into this fact block table. Notably, we don't do those like placeholder rows like we did in the dim. Like you don't see the union to that like unknown row those really only make sense in the context of a dimension table. The next one, I'll kind of like dig into this one. This one's a bit more interesting. So here we're taking those individual block source data, and we're going to create like an aggregate table about just different network stats at a daily level. So we get, again, all the source block data. We're creating those flags just based on some floor division or whatever to see, if it's a halving block or a difficulty adjustment block. And we do the same deduplicate layer. So there is some code duplication, with this. If you're using the same data sources in multiple models, you're inevitably going to have some code duplication. But then we have the aggregate one, and I think this comes back to your question. Where would you do data transformations and aggregations and things? So here we're just aggregating everything at a daily level. If this was the pool level stats table, you would maybe have you would have a group by date, comma, pool. But here we just want total network level stats at a daily level. So we have the date. This is looking at individual blocks. If any of the individual blocks on that date was a difficulty adjustment, we're going to say this date has a difficulty adjustment. We're going to count all the blocks for a block count, right? First and last block, how many different pools mined blocks on this day, total mining rewards, total transactions on the whole day. This is a fun one. So I don't know if this is an industry standard term, but basically when we were looking at some things at for a daily report, well, difficulty doesn't really work at a daily level. It works at a block level, right? The difficulty adjustment happens at a particular block height. So we came up with this term, difficulty weighted average. So we're just creating a blended difficulty level for the entire day. And the way we do that is, I'm going to look at this inner query first. So we're getting those daily aggregates. We're joining back the individual block data on the first block height, where we have a difficulty adjustment, and that individual block is difficulty equals true, adjustment equals true. So anyway, we're basically getting what was the first difficulty on the first block height of the day, and what was the difficulty at the adjustment block coming from this D2 alias. And then we're calculating the amount of time spent at each difficulty level during that day. So we have the duration first, duration second, or last rather, and the difficulty first, difficulty last. So that's the inner select, and then the outer select here, we're basically taking the first difficulty times the duration spent there over 86,400, which 86,400 is the number of seconds in a day, right? So that gives you like a proportion of the day spent at this difficulty plus the proportion of the day spent at this difficulty. We add those together, we have the full 86,400 seconds in the day, and that's our difficulty weighted average. We use that further down in another way, but here, now we're just relations. We're just going to join our fact table to any dimension tables that it will have a relationship with, which in this case is only the date dimension. So we really only have one row per day in this final fact table here. And then I am still doing more data transformations here in the standardized layer. So sometimes, this is just new derived columns. So I'm using that difficulty weighted average to calculate, based on how many blocks were mined and what was the difficulty at that daily level, what is the estimated hash rate of the entire network. So that is the main reason we got that difficulty weighted average, but it comes in handy for other types of metrics as well. And then things like the average fee rate and stuff. So we're deriving some extra columns in here basically, and also scaling stuff to BTC. So now we have sats and BTC scale amounts for everything. So I'm going to run this whole model. Okay, so now we have a date ID, which is going to join back to our date dimension, some flags for the adjustments. You know, we have the difficulty at the start and end of the day, plus that weighted average, and all our aggregate metrics for the whole day. And this is that estimated hash rate that we derived. So let's see, we're on, this is, what day? So this is December 1st, 2023. So our, in exahash scale, you know, we're at 570, roughly. It bounces up and down because of that, you know, because of the mining luck and different block counts coming in. But basically, it looks like we're in a 500 to 600 exahash scale in that time period. All right, so it's got about 8 minutes left. So let's create the last fact table. There's two more, actually. One, this is the same thing. It's all the same stats, but it's broken by your mining pool. So the data granularity of this is 1 row per day per pool. So we'll see that when we join to the, you know, we took all of our source data, the pool hash rate at a daily level. Again, we just had Foundry's hash rate in this source. We deduplicated that. And then we had everything aggregated from the block data by date, by pool. And then we're also getting some network level data to get the estimated pool hash rates in the same way that we did the estimated network level hash rate. Finally, all that stuff joins to our dim date and our dim pool. Yeah, I'm skipping over some of the stuff I wanted to point out, but just in the interest of getting to the final OBT layer. Okay, so we created that new fact table, which is 1 row per pool per day. And you can see we're sorting by date and then sorting by block count descending. So here, I'll just actually write like a query here where we will join. So this is pool stats. We're going to join dim pool on pool ID. And what do we want to see? And we'll join to the date dimension too. On the date ID equals the PS date ID. Okay, so we're taking our fact table and we're joining it to the date dimension and the pool dimension. And this is basically how the OBT models work, which we'll see in 1 second. But basically just to show you that fact table we built, if we have our d.date, our p.pool name instead of this, you know, hash ID, and our ps.reported hash rate, let's just do exahash scale, and the ps.estimated hash rate based on the block count of, you know, that each pool had that day. And yeah, let's see what that looks like. Okay, I need some aliases here. Okay, so on this day, December 1st, AMP will mine the most blocks. Let's get the block count in there too. Okay, it looks like there is a tie actually. But we can see, you know, we have the Foundry reported hash rate because that was one of the sample data files we loaded in. We didn't have that for any of the other pools. But we have the estimated hash rate based on the block count and the difficulty of all the pools. And then the next day, 12/2, looks like Foundry mined more blocks than Mempool. So we're on top here. So that's what we get from joining the fact table to the dimension tables. You know, we could, since we're going to run out of time, let's just like, first of all, does anyone have any questions? And then second, like we can try to just write an ad hoc query that would, you know, basically become an OBT using this fact table with the joins here. Yeah.
Would you always inner join?
Yeah, also a great question. The reason we're always able to inner join is because in our dimension tables, we built in that placeholder row. And in our fact table, I kind of skipped over this part. When we build the fact table, this is the relations to the dims, we're going to left join to dim pool. And then we're going to coalesce the pool ID to that 0 that corresponds to the placeholder row. So if we're, now that those two tables are built, the dim table has this placeholder row in it, and the fact table, when we built it, if we weren't able to find a match in the dim pool table, we just coalesced and defaulted to this unknown pool. So that enables us to always have an inner join at the query or like view level. Yeah, so that's why basically we do these placeholder rows to begin with, is so that you can always have an inner join, which is more efficient, and it just gives you like better guarantees about not accidentally, you know, truncating the resulting data. Let's do something kind of fun. Let's just do the date. We're just going to slice on if it's a ant pool related pool. And let's do a sum of block count and a sum of all the hash rate. We don't have the actual hash rates of each pool, so we'll just have this baseline, you know, estimated value, estimated hash rate. So, and then we'll just, let's see, we'll group by the date and that flag here. Okay, why is it yelling at me? Oh. Okay, so now we just have 2 rows for each day based on that flag, right? So it looks like on this one day it was 50-50, almost 50-50. So actually the ant pool associated pools mined more blocks than all the other pools combined on that day. The next day, you know, it's pretty even day to day here. You'd have to look at this, you know, maybe over a longer time period. In fact, we could remove the date completely. I got 1 minute left here. Let's remove the date and just, I think the data set that I loaded in was all of calendar year 2024 plus 1 extra month on either side in case, you know, I had some like sort of look back or look forward metrics we could have done. So I'm gonna just remove the date dimension and remove the group by. So this is a full year plus 2 months of data. And it looks like 29,000 blocks versus 33,000 blocks. So yeah, almost half the hash rate is that, you know, part of that ant pool group of pools. Yeah, any questions or, you know, other things we could try to do in a minute? And if anyone has questions about DBT or like, you know, wants to see some of the DBT code and how we automate these model builds, I'm happy to talk about that stuff. It's a lot nicer than traditional like SQL migration files and all that stuff. So, cool. Thanks, everyone.
Say what? Started. I'm going to be walking through how to create a new node policy for Bitcoin nuts. First step is going to be obviously to clone the repository. And that's just on GitHub, Bitcoin nuts /Bitcoin. So the first step to creating a new policy is to figure out what you want to filter, or prioritize for that matter. For today, we're going to start with Citria's Watchtower challenges. So we've got the easiest way is usually to look at an on-chain transaction, but since this one's not a very common one, usually it's only in a abnormal circumstance anyway. You have to look at the code, and you can see how the transactions are constructed. So you can see these, it's usually 3 outputs, 2 fake pay to taproot, and then an op return that's 80 bytes. So that's going to be the basis. So the most important, well, maybe not the most important, but first step is to add an actual option. Some people may not want to use the filter, some people may. By default, it should be off in the code. So down in the policy, policy.h is where the defaults usually get defined. We define a default, just set to default false. And then in mempool args.c++ under the node directory is where you actually load the value that's been set in the config file. This is fairly straightforward. You have to add the option to mempool options.h as well to actually set it to, and then in init.c++ you document it. And if you don't document it, you'll have the problem that the checks will reject the option entirely, so it does need to be documented, or at least added to the argman. Once you do that, you can get right into actually making the policy. This is fairly simple as well, actually simpler than adding the argument. That can be in validation.c++ sometimes, but usually it's in a policy file. In this case, policy.c++ is where the standard transaction function is. There's multiple in standard functions, but the one we have to look at it at the transaction level because it's matching based on multiple outputs. Depending on what you're filtering, you could have it just be based in the output format itself or the input format. But here we are, to keep it simple, we're just counting the number of pay to taproot outputs. So we, as we go through the outputs, we check if there's witness v1 taproot, we just increment the number. And then down here, we can simply look for the one data output, the total number of outputs being 3, the number of pay to taproot outputs being 2, and that adds up to cover all 3, and then make sure the option's actually on and potentially reject it. And the maybe reject is actually a macro in knots that checks that it's not been overridden by the user. When they send a raw transaction, they can specify which options to override. So that's it. How simple adding the actual code for the policy itself is. And then you no longer have to deal with that. Then after that, it's pretty much just boilerplate stuff that you add to the GUI. In the options dialog, you need to add a, in this case it's Boolean, so we just do a checkbox. Can add a description so the user actually knows what it does. I guess we have to open the file here. Oops. File. And you can do some of this in core. The GUI part's definitely going to need knots because only knots has it in the GUI. So the set enabled there is because it's part of being in the standard transaction function means that it only runs if non-standard transactions are being rejected. So we have to have it so that when the non-standard transaction option is enabled or disabled, the checkbox itself is accessible. So if someone enables non-standard transaction acceptance, the checkbox for filtering Citria and a bunch of other stuff is disabled simply because it will no longer be effective. The list of strings here, which file is that in? That's an options model. Oops. So this list of strings here is mainly so that if the command line option is provided for reject Citria, it informs the GUI user that the configuration file option is being overridden on the command line. And then we've got a getter and a setter for the option, and as well as an options model, there's a, in the header, there's a enum with the various options that is used for within the GUI deciding what to pass around. After the GUI is done, it's usually best to have at least a test or two. For the test, just modify an existing standard transaction test. We first create the transaction that we want it to match. In this case, we're manually creating the pay to taproot outputs and also a op return output of the correct size, which you'll have noticed in the filter, we don't actually check the size. You can be as specific or inspecific as you need to be. In this case, there aren't likely to be any false positives. Need to make sure the other policies don't impact your test. The default max data carrier bytes in knots is 42 bytes, but since this is using an 80 byte op return, we have to increase that to 83 for the tests. First, we also initialize the policy option to off. We make sure that with the policy off, it still says it's standard. And then we turn it on, check that it rejects it. And then we change it so that it no longer matches the policy and check that even with the policy on, it doesn't match other stuff. And that's important because you don't want it to accidentally filter more than it's supposed to. Then we turn it back off, set things back up how they were before the test so that it doesn't impact other tests. And when all is said and done, you can start the node, and you've got the new policy option right there in the settings. Right there. So you can turn it on or off. If you would want it to be on by default, you go back into the policy.h file. You change the default here, but also there's a feature in Bitcoin Knots where is my files? Sorry, I'm not used to this computer. There's a feature in Bitcoin Knots called Core Policy, so that if this feature is enabled, you want the defaults to remain the same as Bitcoin Core. So if you change the default anywhere else, you need to add it here. Actually, false is not going to work because it needs a string. And that way, if core policy is set, it sets it back up to the Bitcoin Core defaults. Any questions?
Thank you. It's more higher level, I guess. Like, is there a way for example, a mining pool to recognize blocks compiled with knots as opposed to core? Is there like a differentiator that can be seen by their templates?
To an extent, only because Bitcoin Core doesn't really give the block creator any control over how the block is created. They pretty much follow very well-defined policies, and you can usually probably pick up on that, whereas if someone's using knots, they may very well have different deviations from what Bitcoin Core would do for creating a block. One policy that is enabled by default in knots, and some people leave it on, others don't, is it will start filling the block with coins that are very obviously not spam. They haven't been moved for years or whatever, regardless of what the fee is. And so there's a few kilobytes, maybe 100 kilobytes of that before it starts filling the block based on the fee rate. And that's pretty obvious to pick up. If there is spam on the network, Bitcoin Knots usually filters that out, so that's usually apparent if you've got another node like Mempool Space logging what was visible on the network at the time. Any other questions? Or?
When can I run this filter on my knots node?
It's not part of the official release. I just threw it together this morning. The main point of this is how to make the policy and make it simple. For an actual policy, you probably don't want to have it be as specific. You probably want to have it named in a generic way, so that if someone else starts spamming similar stuff, you can add it under the same option. Just so that users don't have to go set an option every time someone adds a new spam that's basically the same thing. This particular kind of spam is very rare. Even when they launch, it's only supposed to be like at worst 500 bytes a year, so it's probably not necessarily worth maintaining. But for more common spam that's mostly already filtered, and it would be easy to just open a pull request to Bitcoin Knots. You could open it to Bitcoin Core as well, but who knows if it's going to merge anything at this point.
So they often claim that spam filtration is a cat and mouse game. So there's already a bunch of different types of spam that currently are considered standard. There's BRC20s, there's runes, there's this Citria thing. What if if we start filtering the spam and the spammers get creative and they start coming out with all sorts of different formats? Is there a strategy for knots to sort of stay ahead of that?
Usually
something a little less slow than just putting it in knots and releasing it every few months.
Yeah, usually the more problematic spam is the stuff that gamifies it so that it's basically getting other people to cover the cost of spamming and bypassing the fee market. So they have their own release process they have to go through as well to change the format of the spam. And it's usually slower than, as you can see, it's very simple to just make a policy to filter it out entirely. Right now, there's no way to update the filters without a patch. Not everyone does compile the software themselves, but if they do, it could be patched in pretty easily. Long term, if the spammer were to keep changing rapidly, there might be a need to do something more automatic. I don't think there really is right now, but if you want to write the code, feel free. As far as first step of finding out how the transactions are made, if it's a problem, there's going to be on-chain transactions to just look at and see what to filter. If worst case scenario, if they're gamifying, if they're releasing code to detect it, they want other people to see the spam one way or another. Like if it's a JPEG, they want something to display it. So there's always going to be code out there to basically tell you how to detect it already. And then it's just a matter of porting it and getting rid of anything extra.
Yeah, it seems to me that the faster the filter comes out for the spam, the more demoralizing it is to the spammers, I think, and the more it sort of suppresses demand, economic demand, as they say, for the spam. Yeah, I've just been wondering, we have, it sounds like over 6% of the network is Bitcoin knots or something like that, if you only count listening nodes or something like that. So there's this whole army of Bitcoin knots runners who would be probably eager to update to the latest filters. So I wonder if there's like a more modular way of just kind of saying like, okay, here's the latest spam filters, everybody, go ahead and run them if you want to help, that kind of thing. Just kind of empower the individual node runners to allow them to contribute.
It's possible. I would just be careful with it because you don't want it something where someone can easily abuse it for censorship. Spam filters don't necessarily, they're not very useful for censorship because it only takes one miner to make a block with the censored transaction and it's gone. Spam filters are different. If one block has spam in it, then oh well, it's not nearly as big a deal as if it's every block. So there's a different threshold there. But at this time, there's no way other than recompiling. And that it's possible to also just do releases more often. That could be useful also for other bug fixes instead of just updating the spam filters,
Is there any benefit to doing it blacklist versus a whitelist?
A whitelist obviously you wouldn't need to update nearly as often, but probably the biggest hurdle to getting that off the ground is just documenting all the various scripts out there that are being legitimately used today. There is an older whitelist that's still applied to the script pub keys, but it's obviously only covering script pub keys. It doesn't cover whatever witness scripts might be in use. So to actually have a whitelist that applies more generally would require a bunch of initial research into every transaction on the network. I would suggest just write a code that looks at every transaction in the last thousands of blocks and make sure you identify each one, classify each one, and make sure that you're not filtering anything that you don't want to be. And then once it's made, the whitelist can obviously be updated as people develop new things. Testnet's wide open for development, and research. There's no reason to necessarily need to test the stuff on mainnet immediately.
Yeah, I was watching Peter Willis talk on his child pays for parent clustering solution to those like crazy child pays for parents trees that can form. And I was just thinking, man, the original point of this was to get like your one stuck transaction out of the mempool, right? Does NOTS kind of cut off these extended child pays for parent chains that can form?
No, that's just another policy, and you can do that without any of this. It doesn't cross-interact or anything. Child pays for parent has actually been in production on Bitcoin Core and Bitcoin Nuts since probably a decade ago at this point. What Peter's working on is an improvement to it, and there's no reason that couldn't work just as well with everything else.
Okay, I was just starting to, because the stuff I'm doing, I'm seeing all of these crazy blocks where it's like, there's 100 transactions or something that are obviously spending the same outputs from previous transactions in that block, and I'm just like, this is not a monetary transaction. This is somebody doing some crazy stuff, and it just seems like a type of spam, and I didn't know if you guys had thought of that as a kind of spam or not.
Yeah, sometimes it may be spam,
Okay.
and if you want to assume it's spam, it's not going to hurt anyone to delay the legitimate transactions a few blocks. There's actually already a setting in here for how long, for how many unconfirmed ancestors a transaction you accept.
Perfect.
And
Okay.
this is actually still an option in Bitcoin Core. It might be a hidden option, I forget. But that.
Oh, I didn't realize there was an option before. Okay.
But that's something that can be trivially filtered as well.
Okay.
Anyone else?
I mean, I can keep this going all day. I don't know. So I'm sure you've heard the concerns about like partitioning the mempool and driving spammers to use private channels to submit their transactions directly to miners, and that this threatens the public mempool itself and drives, I think they were saying it drives MEV or even NIBL, or it drives miner centralization in some way because it favors the large miners. Do you think this might cause that? Just filtering more spam might cause that?
No, because all the miners that accept direct transaction submissions or prioritization, they still apply their own spam filters, and there's perhaps always going to be some percentage of miners out there that are bad actors and will mine stuff that is harmful to the network. As long as it's not a majority of the network, it's of no relevance, really.
Okay, so basically, I think Mara has a service where they let you submit non-standard transactions, and I think F2Pool has something like that. So that sounds like it would be a pretty small minority.
Yeah, and even those, I might consider them bad actors, at least Mara. But even there, they still have their own spam filters they apply.
So, imagine that, so NOTS has a stricter filtering policy than Bitcoin Core, probably on average.
It's all options, so the user determines what their own policy is.
Sure, but I would guess that most people who are, at least most NOTS nodes runners right now, would probably be people who are trying to have a stricter policy than Core. Well, especially if this new PR goes in and Core makes a release that gets rid of the limits on off return, then probably, I think a lot of the reason why we're seeing an uptick in NOTS nodes runners right now is because they disagree with that and they want to have a stricter policy there. So have you sort of gamed out what would happen if, so 6% of the network is NOTS nodes and 15% of the hash power is mining abusive spam, and then Core decides to turn off all the limits for op return. At that point, it's kind of, so it's hard to say these 15%, this 15% of the hash power is hostile because 6% of the nodes say that they're being hostile, but the other 90 whatever percent that are running Bitcoin Core say they're not hostile. So isn't it kind of hard to make the case that that the pools mining the spam would be seen as hostile in that case?
If they're not going out of their way to mine spam, then it's hard to make that case. But the argument, as I understood it, was that they would go out of their way to solicit the spam out of band, and that's where it becomes clear that they're hostile actors.
Okay, so the fact that they have the private submission thing kind of makes them hostile actors.
If they have the private submission thing specifically to bypass the network's policies, yeah.
Okay, yeah, cool.
Outside the transactions that may be using, Bitcoin as a data availability layer, do you think it might be useful to maybe react faster to transactions that might take up more of your node's processing power than a regular transaction? Is there anything in Core you think could be incorporated into NOTS to further improve, relay policy? I guess that's the basic question, outside of the current filters.
All the filters in Core are also in NOTS. Whether you can turn more of them off if you want to, but they're all there.
Additional filters in NOTS that would be good for Core to add, but they've maybe been too slow or haven't reacted fast enough.
Yeah, the obvious one would be fixing the bug with the data carrier size. Aside from Core's talk about removing it for no reason, it also doesn't match the newer data encoding, like the ordinals and inscriptions. And so there's a fix for that I wrote years ago that has not yet been merged still. And that would be an obvious way to fix it, because it doesn't make sense to let that stuff just bypass your data carrier size limit for no reason either.
How difficult is it for you to update to new versions of Core, and when do you decide to do that, and could you just give a little color on that?
The rebasing is very difficult, largely because of the way Bitcoin Core works with having pull requests rebased constantly rather than just adding fixes as additional commits. I've got a bunch of scripts that help me do that easier, but it's still probably a lot of work that most people probably wouldn't want to do. It would be nice if there was a more decentralization-friendly way that development was done, but got to work with what we got.
Would that be like if Bitcoin Core switched to merge commits instead of rebasing?
Yeah, that would be. There's always the merge commit merging in the pull requests, but if the pull requests weren't expected to constantly rebase, then it would be simply a matter of merging in the latest version of Core.
There's a ton of talk about the spam filtering side of things, but there's tons of other policies that have nothing to do with spam filtering. Could you touch on a couple of them for people who don't even know that that's a thing?
Yeah, I mentioned earlier the block priority. The way that works is by having, it uses the age of the coins that are being spent. So for the inputs, those all have a height that they were created at. And so if a coin was created in a transaction, say, a decade ago, the chance that it's involved in spam is very, very low, because if it was involved in spam, it would have just moved like a block ago. And so by multiplying the age of the coin by the value of the coin, you can get a very good heuristic of certain transactions being unlikely to be spam. And obviously, day-to-day transactions are not likely to match that heuristic, but it at least gets some level of legitimate transactions in that. Even if the spam were to somehow trick all the filters, or to be several blocks worth of spam that's tricking all the filters, you would still have that threshold of legitimate transactions that get prioritized before it. The fee itself, the ordering by fee, is itself a policy. It's not one that's currently very configurable. Knots does have an option to change the virtual size of inscription bytes. So if you want to allow inscriptions on your node, you can allow it and then just say they have to pay as if the inscriptions are the same as op return data. They don't get any discount for the data. You could also penalize it and increase the amount that is required for inscriptions and op return data if you want. You could say they have to pay 2 or 4 or 10 times as much as a real transaction. Did you have any other ones in mind that I should mention?
The limits of policy is just a lot. Like you could do crazy things. Like you could say, well, I only accept op returns that are exactly 23 bytes. It's not just spam filtering. You could do like the block priority size thing is a great example because it's not necessarily anything to do with spam. And there's like the DOS protection filters and things like that, which aren't necessarily policy, but there's like obviously certain types of transactions that need to not end up in Mempools.
Right.
Yeah, I just wanted to make sure that people realize it wasn't just for spam filtering. There's tons of other stuff that policy is for.
The spam filters just happen to be the easiest ones to demonstrate in a mere 30 minutes.
Exactly. I just wanted to touch on that to make sure that wasn't lost.
One that has been requested more lately is just getting rid of the witness discount entirely, and that's not supported today, but maybe I'll add it because there's multiple people demanding that, wanting that feature.
we live? All right, great. Thank you guys for coming to my presentation, which is my testnet workshop. We're going to build a testnet, and you're all going to have your own testnet by the end of this presentation, pretty much by the beginning of this presentation, and then I'm going to go over the flow of what we're going to do today. The first thing you should do, I recommend, is you get out your laptops. We will be doing some coding and banging around on keyboards today, so get those fingers ready, lubed up. Let's do a finger exercise. Everyone raise up your fingers. Do this. Let's crack each knuckle. Very good. You're ready to code. These two links are useful. I recommend pulling them up. I'm going to show you what will happen if you do. The first one will bring you to testnet generator, which is what we're going to be using to make our testnet today. And this will tell you a little bit about what it is and why I made it. The other thing we're going to do, we're going to add CTV to our testnet. So we're going to make a testnet, and then we're going to add CTV to it, and we'll see how that works. So that is the plan. First, I'm going to go over what testnet generator is. Then we're going to add CTV to your own testnet, and then maybe we'll make a CTV transaction if we have any time left over at that point. Sound like a plan? All right, let's get started. You all have these links pulled up? What'd you say? Okay, so Testnet Generator is an app that I made, I don't know, several months ago, 6 months ago or so. And I made it because of my frustration with using other testnets. So let me just give you an example of the kind of frustration I have when I'm making a Bitcoin application. So perhaps I want to make an application, and I'm testing it, and I'm ready to see if it works on testnet. So I'm going to go to, what testnet should I use? What's your favorite testnet? MutinyNet? You guys like MutinyNet? So let's go to mutinynet.com. And it's not loading very fast, is it? Okay, so here we got a blockchain that is similar to Bitcoin's blockchain. It follows most of Bitcoin's consensus rules. It's got some soft forks added in. Very happy thing about this one is it's really fast. Blocks come every 30 seconds. And they have a little faucet. So if I go to faucet.mutinynet.com, I can use a faucet to get some money. However, you need to have a GitHub account. They have this little faucet that'll give you a bunch of testnet coins or, MutinyNet coins. And they have spammers who come and spam their faucet and constantly say, give me 1 million coins, give me 1 million coins, give me 1 million coins. And it sucks because spammers are just awful. And so at some point they said, we're going to require you to have a GitHub account. It's not much of spam protection because GitHub accounts are free, but at least GitHub will try and make you fill out captchas or something whenever you're trying to create an account. And I don't know, they think it helps. I don't want them to know my GitHub account just because I'm using their faucet. So so I'm stuck. I can't use this because I don't want them to have my information. So I decided to make a version of testnet that I wrote, and it does not have any limits. So here is my testnet, and it just starts up and doesn't have any blocks in it. If you look at the code base here, this is a version of Bitcoin that I wrote in HTML. It has a validate transaction function here, and it'll go through all of Bitcoin's script. It checks taproot. It does all the sig hashes. It knows what the different opcodes are. All of this stuff in a total of 3,000 lines of code. If you look here, about 3,000 lines of code. It has a full version of Bitcoin. Well, no, not full. It doesn't follow all of Bitcoin's rules. It does, but let me just show you how this works. I'm going to generate I have a little wallet down here. You see this wallet? It says your address. That's a Taproot address. And I currently have 0 Bitcoins. I'm going to generate a block. Generated a block, and check it out. My balance went up to 50 Bitcoins. I've got 50 Bitcoins now. And I can generate 5 blocks. And now I have 300 Bitcoins in my wallet right there. So that's pretty cool. You can create Bitcoin transactions. Let me just examine one of these blocks here. If you click a block, it'll show you there's only one transaction in this block. It tells you when it was made. It's a 50 Bitcoin subsidy block. You didn't get any fees in this block because there's no transactions other than the Coinbase. But it has a little Coinbase transaction that deposited 50 Bitcoins into this address, which is the same one on the home screen. Let's just see what it looks like if I make a transaction. I'm going to send some money to myself. I will send, I don't know, 50,000 sats. I will use a fee rate of 1 because no one else is using this testnet, so there's no competition to get into a block. And you can see that my balance went down a little bit. You might be saying, well, wait, it didn't go down 50,000. That's because I sent it to myself. And it detects that, and it's like, oh, you sent it to yourself, so it didn't really go down. The only thing I'm missing is the fee. I paid a 300 sat fee. But if I mine this block, let's see, generate block. This little block up here has 2 transactions in it. And now my balance is 350 because I got the fee. I got the fee back to myself, so all the money back in my wallet. There's the Coinbase that put 50 Bitcoins and 300 sats into my address. And then there's this transaction, which sends money from my address to my address, 50,000 sats. Pretty cool. We got a little blockchain, a little testnet here. This does not follow all of Bitcoin's rules. For example, I'm going to generate blocks at a rate of 1 block every half a second. You can't do this on MutinyNet. Even MutinyNet only gives you a block every 30 seconds, but why stop there? We can make them really fast. And this is not something Bitcoin can do. Bitcoin has difficulty adjustments and halvings and stuff, and mine doesn't know about any of that. This also doesn't have a block size limit. BSVers are welcome to use my testnet. Yeah, so I made this so that, also look at this balance over here. Look at that, Bitcoin's just going up really, really fast. You got plenty of Bitcoins, plenty of testnet sats on my testnet. So why did I make this? Well, I made this because of all of these reasons. I don't like the rate limits that are placed on other testnets. I don't like the fact that blocks are slow, and even on MutinyNet, if I'm testing something that needs like what's it called? A few blocks for a time lock, like I have to wait 6 blocks or something, I have to sit there and wait 6 times 30 seconds for it to go through so I can do the next part of the transaction. This one, it's real easy. Click, 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 and then I can do the next part of the transaction. The other thing that I made this for is because regtest sucks on Bitcoin. Regtest sucks on Bitcoin. So just as an example, I'm gonna try and let's see if I want to use regtest mode, which is what everyone else does. Then the first thing I need to do is download Bitcoin Core. So I'm gonna do git clone https://github.com/bitcoin/bitcoin or not. I'll do knots. Why don't we do knots? And hit enter, and it's really easy to run Bitcoin in regtest mode. There's no problems at all with doing that. All you got to do is download Bitcoin Core. Or Bitcoin Knots. You just got to download it. Where is it at? 3%. See the problem? Yeah. If you want to run Bitcoin in regtest mode, you got to wait until it downloads. You know what you got to do if you want to run this one? Just refresh the page, new blockchain, you're basically in regtest mode. This is great. So that's why I made it. That's a way better user experience. Okay, so that's where we're at. What I want to do is I want to add, so let's see, on my list of things to do today is go over what testnet generator is. Do you guys feel like you got a good grasp of what we're dealing with here? It's the worst possible blockchain, but it does understand Taproot and Bitcoin script. I want to add CTV to it because that's been making the rounds recently, and CTV is pretty cool. So I think that's what we'll do today. We're going to add CTV to this testnet and see if we can make a CTV transaction. You got a little question, Luke? Oh, sorry, we got the microphone.
Most of the time, if I want to use a testnet, it's because I want to interact with some other service that's offering a testnet service. Is there any way to reconcile this with other services that other people might run?
I'm not. So let me try and state something that sounds similar to what you said and see if it matches. When I'm using a testnet, often what I want to do is share whatever I did on Twitter. I want to say, look at this cool transaction I made. Here's the block. You can go into it. You can see my transaction. You can click the script and expand it, and it'll show you some wacky thing I made. Is that what you're talking about?
No, I'm thinking like if I'm testing Datum Gateway, for example, I want to interact with the Ocean testnet, or
does it have an API?
Or like I'm sure there's a Coinbase testnet or a Kraken testnet to test things along interacting with exchanges or whatever.
What I've done is there's not an API. I'm sorry. I don't have an API. One thing I also want to add, maybe we could do that in another workshop someday, is add something like, what's it called? The eSplora API. I could add that so that you could do that with it. Right now, the only thing I have is you can make a shareable testnet, and if you click this, this gives you two links. This one is where you can generate blocks on your own. You can generate blocks in your testnet, and I'll show you what that looks like in a second. This one is a shareable link, and people who visit this link cannot generate blocks, but they can view things that you've made. And basically what I'm doing is if I generate a few blocks on here, every 5 seconds or so, it's going to upload all of my blocks to a Nostr relay. And so if I come over to this one, which is currently syncing, it just synced those 5 blocks, and so other people can view what you've done in your thing. So if I make another transaction here, sending myself 10,000 sats, and then generate that block. After 5 or so seconds, we should see it pop up here. Actually, I think it'd be like, yeah, there it is. So now this guy is able to see my block, and he's able to see that transaction in it. So this is a way to make it so that you can share this data with other people. It's the foundation, but I haven't made an API yet to where you could just like query a Nostr relay and say, what's the stuff in here?
Hypothetically, some service could support this and then give you an alternate website where it interacts with your blockchain instead.
Right. What I want to do is make a library where you can either plug in mutinynet.com or mempool.space or some eSplora interface, or you can give it that link at the bottom, and it'll have the same API for all of them, where you can see how many blocks are in there, see what block you want, and all that data.
So, I mean, basically the server for this is running in a browser, and it's connecting to Nostr relays, and that's how it's sharing data. So I guess you could have Kraken or whatever send messages over Nostr to this, or receive messages over Nostr from it, and use that as the interface.
Yes, you could. You could also just download this code base is just a single, what's it called? Where's the, if I view, not that one. If I view this in source, the JavaScript is all just in this, this file called, this variable called testnet generator. So all of the data goes into this one file. You can just import this into like a Node.js project and then run one as a server, like an actual server. And it would be very easy to do because this is all standard JavaScript. It's not doing anything unusual. Well, other than running a blockchain in the browser. I don't know what that means.
If you fetch these blocks out of Nostr and feed them to a Bitcoin deal.
No, they're not valid Bitcoin blocks. The blocks in here do not have difficulty. So if I show you what the block or not, hang on. If I show you an example of a block, so blocks generate one. I now have a block in here, and its hash is just all zeros. And if I make another one, that one's just all zeros and a 1. That's clearly not going to validate. if you try to pass this through a block header thing and see if it hashes to all zeros, it will not.
That's a lot of proof of work, man.
So much proof of work. If you look at my block header is what fees did it pay, what's the timestamp, and a list of transactions. No Merkleization of the transactions here. It is just a list, an array of transactions. This is not a valid Bitcoin block. But it doesn't need to be, because what I want to use this for is to play around with Bitcoin script, and I can do that without following the other consensus rules of Bitcoin. And I want to share that on social media and say, look at this weird transaction I made that does something with BitVM or something with CTV or whatever. So that's the purpose of this, and no, it won't work with Bitcoin Core. But hey, if someone wants to, it's just a single HTML file. If you want to make a version that's valid with Bitcoin Core, have at it. And then say, I made my own testnet. I did what he said. Okay. So are you guys ready to do, the second part of this is that I want to get CTV, I want to add CTV to this so it supports that. You guys want to get started hacking in some code? Okay, cool. So to do that, the first thing I want to do is load in my CTV hash generator. So the prep work I did for this, the only prep work I did was I made a CTV hash generator. So if I import this code into, and it only depends on having the TapScript library, which is the version of Taproot that we use in JavaScript, that I use in JavaScript. So if I import all this code into my software tool, which already has that library in it, this should all just work. So let me just test this. I'm going to put that in there. Now I should have the ability to create CTV hashes. And so I will try one. I'm going to go here, this website, which I will add a, where can you find this? Oh, I know where you can find it. If you go to this link, CTV generator, that will take you here and look around for the test vectors. I talk about the test cases I'm testing against are available here. And this link here, this is a JSON file. This gives you a bunch of test vectors for CTV. We're going to need those while making this thing work. So that will just take you to this thing. And he has a list of Bitcoin transactions. And he says here, if you test what CTV hash you should get if you're spending from input 0, it should be this one. And if you spend from input 1, the CTV hash you get should be this one. So we can test that with my little CTV hash generator. I can say generate, wait, where was it? What's the name of this function? Get standard template hash. So get standard template hash. I can put in this raw Bitcoin transaction, and let's see, which one do we want to do? Input 0 is the one I want to test, so I will test input number 0. And if I look at what it returns this hash, 2D28 whatever. That should be right here. And you can see, I'm going to make that a little bigger for you. 2D28 is what we should get. So the CTV hash generator is already working. We've made progress on our goal. So now what I want to do is not just have that as, I want to make it so if I refresh this page, it'll still be, it'll be in my code without, like, if I refresh the page right now, I have this function get standard template hash, but I just pasted it into my console, so if I refresh the page, it's gone. I don't have get standard template hash anymore. I want to make it so I can refresh the page and it'll still be there. To do that, I'm going to clone my GitHub, and then we'll keep going from there. So I'm going to make a new directory, make dir, Testnet workshop. That's what I'll call this directory. We'll go into Testnet workshop, and I will git clone github.com/supertestnet/testnet generator. And then I can go into there. And it's only got these 3 files. It's just the index.html file, a README, and the license, which is public domain license. So I'm going to open up index.html in Sublime Text Editor, which is right here. And now if I add the template hash thing into there, get standard template hash, it should be an improvement. So I'm going to go to the bottom of this. Where does the code end? I think can't be that one. Testnet generator equals. Yeah, I want to do that. It ends on line 2756. So I'm going to add the template hash generator to the bottom of this as a new little function. And so now if I open up this file in my browser, which should be Bitcoin projects, testnet workshop, testnet generator. If I open up this in my web browser, now I should have testnet generator.getStandardTemplateHash, and I have that function in here. So that is an improvement. Now if I refresh the page, it'll still be there, and we're making progress on our little application. I think if I run this, it's going to have some, it's going to complain. So let's try and run that CTV thing again. I'll move this over here. I will once again try to do index 1, or index 0, I mean. And it says reverse hex string is not defined. So let's find reverse hex string. That is a dependency for this program, and I don't think I already have that. Oh, I do. I have testnet generator.reverse hex string. Great. So I can just find all instances in this and replace them with that. There's another one. There's another one. There's another one. Shouldn't be that many because it's not a very long function. Great. So that should fix that. And I shouldn't get that error anymore if I try and redo this. And I did not, but I got SHA-256 is not a function. So I think I already have SHA-256 somewhere else. Yep, I have it right there under testnet generator, because everything's in this one file. I think this is easy to hack on because everything's just in this one little variable. So if I do SHA-256 in my new little function down here, yeah, I can just say testnet generator dot for all of these, and anytime when I see SHA-256, I can just replace it with that, and that should work. There's one. Okay, that's all of them. So that should be done. And let's try it again and see what errors we get. Now it's upset that hex to bytes is not defined. Let's see if I have hex to bytes anywhere. I do. It is under testnet generator, so I can just find it, not that, hex to bytes, and change it to testnet generator dot hex to bytes. So that's there. Any other places where it appears? Yeah, right there. Any other places? No, that is the last one. This one is from other code from before. So that should be fixed. Let's see if it works now. This is how Super Testnet works. I just keep doing this. Oh, it still says hex to bytes is not defined. What line? 2825. Okay, so I should go down to line 2825, because I thought I got all of them. Testnet generator dot hex to bytes. There's another one. Testnet generator dot. Any other ones? No, now it's happy. And it gives me, that doesn't look right. That's not the same one. Well, now what did I do? Oh yeah, it is. I just looked at the second. 5F3BC, 5F3BC. I just did a different transaction. Cool, so now we've got the CTV hash generator function working. I want to add this as an opcode to my script. So if I go to, I think it's validate TX is the function where I check the Bitcoin scripts in here. And if I scroll down to look at where it starts looking at opcodes, here's some. This is where it's doing opchecksig, which is a long one. Opchecksig add is about the same length. These are different opcodes that it supports. Let's find another one. There's opswap, op2drop. I want to add a function here for what it should do if it encounters opctv. So I will go all the way to the bottom of these else ifs, and this is a long function. It looks like it's at the bottom around here. Opcheck sequence verify, so that one ends here. So we will add else if. We're looking at op check template verify. So this is saying if we encounter the opcode opcheck template verify, what should we do? Well, if I remember right, I need to check the BIP and see what opcheck template verify. I want to see how many parameters it takes. So what is its BIP? I think it's bips.xyz/119. It might just take the hash. We'll find out. Let's see. This BIP proposes a new opcode, and it's going to be based on NOP4. So actually, I should probably add that. Or element equals opnop4, because I think that's going to be supported in my in the tapscript.js library. It doesn't know about check template verify, but it knows about opnop4, so then I can use that as a replacement. If I run into that, then what do we do here? There is at least one element on the stack, fail otherwise. The element on the stack is 32 bytes long, and it matches, it is equal to the element stack, otherwise fail. So that is the logic that we need to encode here. So what I will do is check if we have so this params thing, the params array is an array of things that are currently on the stack. And the first thing here says there need to be at least one element on the stack. I call the elements on the stack parameters, or params. So I need to check that it has a length, and the one I replaced here was already doing that, so that's good. It's already doing the first part. It is failing if there's not at least one element on the stack. Then I need to check the element on the stack is at least 32 bytes long. So what I can do here is if params.length -1. This is checking, or this is grabbing the last element on the stack, and I will say if its .length does not equal 64, its length needs to equal 64 because in JavaScript, a hex string of 32 bytes is 64 characters long, because every hex byte is 2 characters in JavaScript. It's like AA, for example, is a hex byte. So I need to make sure they are 64 bytes long, and if it is not, then I will say param had wrong length, and I will throw an error for that. So that means I need to go all the way up to, what was the previous error I just replaced? Input whose stack is too small. I need to add one here, var param had wrong length. At first, that will be set to -1. That means no input to this transaction had a parameter of the wrong length. If we throw this error, then I will set that to be whichever input had one. And then I need to go to the bottom of this function and say, if we run into that error, if param had wrong length and it is greater than or equal to 0. That means if there is an input, if one of my inputs had a parameter of the wrong length, then we need to throw an error and say that TX was invalid because input this had an element on the stack that was the wrong length. And by throwing this error, I will not let the script continue. So I have fulfilled this. The element on the stack needs to be 32 bytes long. It says NOP otherwise, but I'm going to have it just fail. It'll fail if that happens instead. Because this is my testnet, and I can make it do whatever I want. I don't have to follow the official rules. Then I need to check if the check template verify hash of the transaction at the current index is equal to the element on the stack. Fail otherwise. So what that means is I need to pass the current transaction and the input number we're checking into my get standard template hash thing, and check if the hash I get out is equal to the one that's on the stack. If they're the same, we continue. If they're different, we fail. So that sounds easy enough to do. Param had wrong length is where I want to go. And I want to say I don't need to reverse the thing, so that's not necessary to do. I will instead say How do I check it? I need to get the transaction hex. So where's the transaction hex? That should be up near the top of this function. What do I call it? Validate TX is just, it's the first parameter is called TX hex. So that is what I will pass. I will say var hash I need. Or actually, no, I will call it valid CTV hash is testnet, or it's a wait testnet generator dot get standard template hash. I will pass in my TX hex, which I already have from the top of this file, and I will pass the current index number of the current input. So that will give me the valid CTV hash, and now I will just check if they are the same. If the last element on the stack, which is this, is not equal to the valid CTV hash, then I will return another error. So, similar to this, I will say input with invalid CTV hash equals that. Just as I have param had long length, I also now need one that says if input with invalid CTV hash is greater than or equal to 0, I will return an error and say that TX was invalid because input with CTV hash had an invalid CTV hash in it. There we go. And lastly, I need to put that at the bottom. Param had wrong length. I'll do it. Oh, I think that's good. Input with invalid CTV hash. Okay, I think that is all I need to do. No, I need to go back to the top. Param had, and add one right here. Var this equals -1. Okay, that should match. Now, we should be done with the second task on our to-do list. So our to-do list said, go over what testnet generator is. We did that. Add CTV to your own testnet. If you have followed along with this, you should have CTV as part of your testnet now. And make a CTV transaction so we can actually just test this thing and see if it works. So how am I going to make a CTV transaction? Well, first I'm going to save this project, and I'm going to open it up in my web browser. And here I've got a blockchain. Let's see if there are any errors in the console. I don't see any. So I'm going to generate a couple of blocks. Okay, so now I want to actually use NOP4 and get a CTV hash. So let me see what I can do here. Normally, what you're doing with CTV is you're creating a transaction with a certain set of outputs, and you're saying if you send money from Bitcoin address that has CTV in it, it has to create this set of outputs. That is what CTV normally does. So I'm going to create a transaction with a certain set of outputs, get its CTV hash, and then we'll make a transaction that follows this rule and mine it, and then we'll make a transaction that doesn't follow this rule and mine it. One of them should succeed, and one of them should fail. Sound good? All right, that is what I'm going to do. So var tx equals TapScript tx create. That is how we start a transaction in TapScript. And it needs to have a set of VINs and a set of VOUTs. So I think for that we do this, and VOUT is also going to be an array. For the VINs, I don't think we care much what the VINs are because CTV only commits to the number of VINs and not their contents. So I'm going to create a dummy VIN. A VIN is basically, VINs and VOUTs are basically the from addresses and the to addresses. But when you're using TapScript or Taproot, your VINs and VOUTs have to have, your VINs have to have 4 variables in them. One of them is TX ID. So I'm going to create a TX ID that is just the letter A repeated 64 times. And if I do that, if I show you what that looks like, we're going to pretend this long string here is our TX ID for this because it's a dummy TX ID. So that is our TX ID, and then we need a vout, and it can be 0. That is the output of the previous transaction that put money into this, that created this input, created this UTXO. And that also commits to 2 other variables, which are in a thing called prevout, in an object called prevout. We need the value, which will make it 100 sats. Doesn't really matter because we're not committing to the details. We just need this dummy input to be in here, and script pub key. And the script pub key, we can have it be a taproot output that also just sent money to this thing on repeat. Okay, so that is our input, and then what we really care about with CTV is our output. So for this, I'll just copy this details. Outputs are simpler in Bitcoin. We just need to know how much money is being sent to someone, which is the value field, and what Bitcoin address to send it to, which in Bitcoin script we call addresses script pub keys. So I will just use this same one again. We'll say we're going to send money into a taproot address that is just the letter A repeated over and over again. So that will be the CTV transaction that we need. That will give us a CTV transaction whose template we need to match. So if I have TX here, then I should be able to get the TX hex by doing tapscript.tx encode that transaction .hex. There is our transaction, and if I tell my testnet, my get standard template hash function to get the standard template hash for this, it should give me one. So I can do, it's an awaited function, testnet generator dot get standard template hash. There's the raw transaction, and we will be spending input 0, CTV hash. There it is. So there is our CTV hash. And now I want to make a transaction that uses this in its script. So what will I do for that? I think all I need for that, I will make a new transaction. Let me see. I want to send money from this Bitcoin address, from my faucet in my testnet generator. I want to send money from this Bitcoin address into a Bitcoin address that has this CTV hash in it and says, the subsequent transaction has to match the template from up there. It has to send money into this Bitcoin address, or this script pub key. So it has to send, actually 100 sats is too small. I should make it more than that, because otherwise it's non-standard. So let me make it 1,000. And that should change our CTV hash. CTV hash is now this. Okay, so I need to make an address that commits to this. To make that, I will need a script. So var script equals this. And the script is going to have the CTV hash on it, which will be this. And it'll use opnop4. Opnop4. So what this script is saying is, we're going to have a Bitcoin. We're going to turn this script into a Bitcoin address, and when we spend from this Bitcoin address, we have to supply a witness. Or our transaction will be introspected, and it'll compare our transaction with this template hash, and then it'll say if the transaction spends to the right outputs, it'll match this CTV hash, and we'll let it go through. Otherwise, we will not. So this is a very simple, basic CTV script. I think that's all we need in there. I can't say object template hash because I don't think TapScript.js has that, but it does have the NOP codes, NOP4. So that should work. I'm now going to turn this into a Bitcoin address. To do that, what I think I do is TapScript address pay to. No, that's not how you do it. I need to look up how to do this. TapScript comes from this JavaScript, this Node.js library by our good friend Topher, who I think he presented in this room earlier today. And it will tell us how to do this. So I need to see, how do you get the tree? Yeah, so if I have a list of scripts, I can get the Merkle tree using this function, and we'll continue from there. So let's see, var script equals, that's going to be scripts now. That is an array of scripts that are allowed in this transaction, but we're only going to have the one. So I will use this function, var tree equals that. Script.encode each one, and tap is not defined, so I need to say tapscript.tap. So now I have a tree of allowable scripts. That's my Merkle tree that we use in Taproot all over the place. And I need to turn that into an address. So I can say var tap key, don't need the control block at this time, equals tapscript.tap, get public key. We need a public key, and we have our tree. For the public key, sometimes I call this the backup public key. So whenever you're making a Taproot transaction, you can have a set of scripts that are allowed to spend the money, but you always have to have a public key path. Sometimes it's called the key path. And that says if you can't spend the money using any of the scripts, you can always spend the money using the public key path. In this case, I don't want to allow anyone to spend money using the public key path, which I call the backup pub key, or using the backup public key. So I'm going to make up a backup public key. And it is going to be it's going to be a nothing up my sleeve number, a Bitcoin public key that no one knows the private key for. So I will use the letter A repeated 64 times again. I use that all the time in my code. And this should give us, that gives us this tap key, which we can then turn into a Bitcoin address. So how do I do that? There should be a function in here. To turn a tap key into a Bitcoin address. He got rid of, so I have to remember how to do it. So I think it is tapscript.address.p2tr. Is it encode? I forget how to do it. Maybe it's from script pub key, and then we can put in the tap key. It didn't like it. Size, oh, yeah, right. It has to be an array, and it has to start with 1. So there is our Bitcoin address. We're using this on a testnet, so I want to encode that in the testnet format, and I will say testnet. And there is the Bitcoin address. So this Bitcoin address is a Bitcoin smart contract that encodes, thank you, Paul. This is a Bitcoin smart contract that says if you send money into this address, the only way you're allowed to spend it is by following our CTV template hash. The money has to go into 1,000 sats have to go into the address we approved on our whitelist, which is just the letter A repeated a bunch of times. Cool, so we've made this. Let's send some money into it. So I will do a send into that address, 10,000 sats. And now we need to spend the money, but I just realized that I'm 6 minutes over my time. My talk ended at 4:15, and the next talk is the debate between Peter Todd and what's his name, Chris Guida. So I'm going to end here, and for your homework, you can do what I've been doing to spend from this address in your testnet that has CTV now. Thank you all for coming, and I hope you had a great time. See you later.